According to IBM, artificial intelligence is a field which combines computer science and robust datasets to enable problem solving. It also encompasses subfields of machine learning and deep learning, which are frequently mentioned in conjunction with artificial intelligence. These disciples are comprised of AI algorithms which seek to create expert systems which make our predictions or classifications based on input data. Over the past decade, audio assistants have become very popular. These are devices that listen for keywords, understand certain phrases and sentences to execute desired commands. Machine learning can be used to train such devices to understand previously unseen, more complex words and sentences. In this project, a keyword spotting application was implemented on the MAX78000 Feather board. The MAX78000 Feather board is an ultra-low power convolutional neural network interface engine that enables neural networks to run artificial intelligence computations on tiny edges of IoT. A CNN is a deep learning algorithm that can take in inputs, assign importance, such as weights and biases, to various features in those inputs and differentiate between them. The objective behind this project was to explore the application of the featherboard in fields related to AI, such as voice recognition. The keyword spotting model on the featherboard was trained to listen for and recognize 20 keywords from the 35 keywords in the second version of Google's speech command dataset. The steps involved in this project were model training. It is a process through which the best combination of weights and biases for a machine learning algorithm can be achieved. It enables the minimization of the loss function over a prediction range. The purpose of training a model is to improve its accuracy so that it can detect keywords correctly most of the time. Supervised learning was the machine learning algorithm used to train the model. The training process generally has two phases. A forward phase in which the input is passed through the CNN, and a backward phase in which gradients are backpropagated and weights are updated to improve the accuracy. This phase is also called backpropagation. The second step is quantization. Quantization allows a reduction in the size of the neural network while ensuring high performance accuracy. It is an essential step since the memory size and the number of computations are limited in on-device applications. The next step was model evaluation. Model evaluation was essential for testing the behavior of the trained model on unseen data because that helps us validate whether the model works and whether it makes correct predictions. The fourth step was model synthesis for generating some essential files as well as the synthesized code. The fifth step was building and downloading the firmware image to the featherboard, and the last step was displaying the output. Here is a demonstration of the keyword spotting project. Up, down, left, right, stop, go, yes, no, on, off, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Keyword detection finds its application in multiple spaces such as automation. Today, voice-activated services like Siri and Alexa listen for keywords such as Hey Siri and Alexa to perform different tasks. Machine learning can play a key role in such applications because it can be used to model various voices, accents, commands, and even different tones. The MAX78000 Featherboard enables the implementation of complex convolutional neural networks with low latency and optimized power consumption. Its small size and high capabilities means that it can be used in spaces where machine learning has seldom been used earlier. One such implementation could be the detection, treatment, and surveillance of cancer cells. Cells in our body vibrate multiple times per second. These vibrations are too faint to be heard by us or be caught on video, but they can be converted into sound. The sounds created by a healthy group of cells are very different from those created by cancerous cells. A model could be trained to recognize such differences, and this would be instrumental in detecting cancer or even early traces of it. Furthermore, once cancerous cells have been detected, another trained model could be used to track their growth, pre-treatment, and post-treatment. A nanomicrophone could then be placed in the area where cancerous cells exist, and with the help of something like the MAX78000 feather board, doctors can easily track the cancerous cells. The feather board is a low power consumption device, and hence it can be used in multiple applications in industrial IoT, such as providing voice control capabilities to machines, as well as the remote monitoring of machine plants, turbines, generators, rigs, etc. It can be trained to listen for faults in machines and trigger alerts, preventive measures before breakdowns. Since the featherboard has a camera on it, it can be used to run a facial recognition system. And the next step would be to include the featherboard in a larger project where keyword spotting is just one of many features. Thank you.